right, calculus. There's at least one person out there who is very confused at this point. I don't really know how to fix it. So what I'm going to do is I'm going to go over the last section today. And then I'm going to give you some to try. And then we're going to do a Zoom meeting because you are going to have a test on Thursday. And unfortunately, my plan was that you would have until next Friday to hand in your assignments. And then I got told, nope, it's going to be Wednesday. That was not a me decision, okay? So please don't yell at me. That was not a me decision. That came from above me. So I can't do anything. I can't do anything about that. I just can't. So we're going to go over this last section. This is Monday. We're going to go over this last section. Maybe Tuesday we'll do a Zoom meeting and come prepared with questions and we'll go over them. And then Wednesday will be a study day. If there are things you want me to go over, I can do that. But Wednesday will be a study day. You'll have a test on Thursday, and then you will have nothing else except hand in your assignment on Wednesday, okay? Wednesday by midnight is what I have. Wednesday by midnight. You can't be late with it. You just can't, okay? Because I have been given a very firm deadline of when I have to get things done. And as it is, I am making it so that I have less than 24 hours to mark an assignment for every single student that I have in every single class, okay? So I'm not making this easy on myself either. Like, this is hurting me too, okay? So we're gonna do the very last section. So far what we have done is we have done derivatives of things like ln of 3x minus 7, all right? I want to make a really important distinction with this. This is not ln multiplied by 3x minus 7. This is ln of 3x minus 7. This is not multiplying. This is a unit that goes together. And when we do the derivative, we do the derivative of the ln, which is 1 over whatever I'm taking the ln of, and then I do the derivative of the inside. It's basically the same as the chain rule. If I gave you 3x minus 7 to the 6th, the chain rule says do the outside first. In other words, bring this down, 3x minus 7, and decrease my exponent by 1. Then do the derivative of the inside, which would be 3. So I messed this up over here. So when I do the derivative of ln of 3x minus 7, it's the same idea. We do the derivative of the outside, which would be the ln. When we say the outside here, we mean that outside exponent. Here, the outside is a ln. So I do the derivative of the ln, then I do the derivative of the inside, which would be 3. I don't know why I put negative 5 there, 5. I'm messing up all over the place. So this would be 3 over 3x minus 7, and this would be 18 3x minus 7 to the 5th. But what I want you to really pay attention to is the language that I'm using, because it's intentional. This is ln of 3x minus 7, not ln times 3x minus 7. I make that distinction because in the last section we're going to talk about derivatives of trig functions. So we are going to talk about derivatives of sine, of cosine, and of tangent. So again, if we have sine of 3x minus 7, again, that is not sine times 3x minus 7. That is sine of 3x minus 7. So the same rule that applied for the chain rule, that applied for doing ln, the same rule is going to apply here. I'm going to do the derivative of sine, and I'm going to leave the inside alone, and then I'm going to do the derivative of the inside. So first off, you need to know what the derivative of these things are. So I'm going to write that up in this corner, okay? The derivative of sine x is cos x. The derivative of sine is cos. The derivative of cos is negative sine. Okay? They actually go through this by first principles to prove to you why. All through, it really starts at the top of page 512, okay? So they actually do all this by first principles, which is crazy, okay? I'm just giving you the answers. And the last one is, what is the derivative of tan? Tan's always weird, right? So tan is secant squared. Now, very rarely will we be using that one. More often than not, it will be sine and cos. So there is a definite order in which you have to take the derivative of these things. So I am looking at example 1. There is an A, a B, and a C. We are going to do A, B, and C. Now C, they give 2 ways to do it. I am going to do it both ways. One way you need to know a trig identity, the other one you don't. Okay, so one you need to know a trig identity, the other one you don't. All right, so 1A, example 1A, page 513, is y is equal to 2 sine of 3x plus 4. So this is one whole unit. It cannot be separated. It is sine of that. It can't be separated. This is 2 times sine of. So I'm multiplying 2 things. So here's my f, here's my g, okay? So if I'm going to do the derivative of this, I am going to do the product rule. So the product rule says g f prime, but the derivative of 2 is 0. Now remember, all of that is a unit, so it's 0 times this whole thing. So technically, that's all just gone, all right? Plus, here's where it gets tricky, f, which is 2, but I have to do the derivative of g. So again, first, I do the derivative of sine. I do the derivative of the outside, leaving the inside alone. So the derivative of sine is cos, and I leave the inside alone. Then I do the derivative of the inside. Well, the derivative of 3x plus 4 is 3. So if I'm going to clean this up, well, all that's just gone. I have this is 1 unit, cos of 3x plus 4. That's all 1 unit. This is tacked on to the end, so it's multiplying. So I can multiply this 2 and this 3 together to give me 6 times cos of 3x plus 4. And that is my answer. All right. B. B says y is equal to cos. Now they really throw us a monkey wrench. They put a cubed on the cos. Cos cubed of 4x squared minus 7. I am not multiplying anything in here because this is cos cubed of 4x squared minus 7. It is not times 4x squared minus 7. So the thing is that we have, forget about the end for a minute, we have a cos cubed. So think back to the example I did before where I was talking about the chain rule, where I had 3x minus 7 to the 6. What did I do? I brought my 6 down, I left the inside alone, I decreased my exponent by 1, and then I did the derivative of the inside, which was 3. Well, with this cos cubed, we're going to do the same thing because it is something with an exponent on it. So here's, and this, we can do the derivative of this. So here's what we're going to do. We're going to bring the 3 down in front, and we're going to leave the cos alone, and we're going to decrease the exponent by 1. All right? Now, this didn't go anywhere. You can't just leave cos squared. Cos squared of what? Well, cos squared of 4x squared minus 7. So all I did was I took the exponent, brought it down, decreased it by 1. That's all I did. So I did the derivative of this, right? I brought the 3 down, I decreased it by 1. Now I have to do the derivative of the cos, just like I did the derivative of the inside. So now I have to do the derivative of cos. The derivative of cos is negative sine. But negative sine of what? Well, negative sine of 4x squared minus 7. So I've done the derivative of the 3 by moving it down in front and decreasing the exponent by 1. I've done the derivative of cos by putting the negative sign there instead. Now I have to do the derivative of the inside, which would be 8x. Okay, so now really what I have to do is I have to look at what, when I simplify this, what can I put together and what has to stay together? Well, this is cos squared of 4x squared minus 7. So all of that has to stay as 1 unit. This is sine of 4x squared minus 7. So this has to stay as 1 unit. So what is not in those units? Well, 3, negative 1, just a negative, so negative 1, and 8x. If I multiply all those together, 3 times negative 1 times 8x, that's negative 24x. And then I have cos squared of 4x squared minus 7. And I have sine of 4x squared minus 7. And that is my answer. Isn't that lovely? All right, so now we get to the one where I can actually do it 2 different ways. I'm actually going to do it by solution 2 first and then by solution 1. So y is equal to 2 sine x cos x. All right? So I can do this. I'll do this. I can do this. I'm multiplying this and this. We'll call this f and we'll call this g. All right? So g, which is cos x, f prime. So the derivative of 2 sine x. Well, technically now I have to do the product rule inside the product rule because this would be f and this would be g, right? So g, which is the derivative of which is sine x, f prime, well the derivative of 2 is 0, plus f, which is 2, g prime. Well, the derivative of sine x is cos x. So I just did, for my big F and big G, I did G, and here is F prime. But in my F prime, I had to do the product rule. A lot of people very quickly catch on to the fact that when one of them is a constant, really all I have to do is, because when you do the derivative of that, it's going to be 0 anyway, so it doesn't matter what that is. You really only have to do the second part. Leave the 2 alone, do the derivative of that. Most people don't even bother to do that part of it because they just go, listen, the 2 is going to be 0 anyway. All right, now, plus, now I have to do f, which is 2 sine x, g prime. Well, the derivative of cos x is negative sine x. I'm running out of space. So if I clean this up, I have cos x times 2 cos x. So that is 2 cos squared x. And here, so that's all that put together. That's that put together. Plus, I have 2 times negative 1. So that's negative 2 sine squared x. So I really have, I could take 2 out as a common factor, and I have cos squared x minus sine squared x. Now here's what I'm going to tell you. At university level and in this textbook, they are going to, I just rocked that, hopefully it didn't go fuzzy. They are going to expect that you recognize that that is a trig identity, that is a double angle identity, that is cos 2x. I'm not going to be so picky. If we were in class and all together and had lots of time to practice this, yes. But at least here, all right? So this was doing the product rule. Now, another option, what they call solution 1, is this. If you know your trig identities, 2 sine x cos x is a trig identity. It is a double angle identity. That's actually sine 2x. And then all I would have to do the derivative would be, first I do the derivative of the outside. The derivative of sine is cos of 2x. And then I do the derivative of this, which is 2. So that is 2 cos 2x. A lot less steps. That's why knowing your trig identities can be a real advantage. It can shorten something a lot. That's why trig identities become important in calculus. All right. Now come the questions where they put everything, and I mean everything but the kitchen sink, together. All right? And the question is going to look very confusing. So I'm going to talk you through it, okay? So they say show that the derivative of 3 ln of tan x minus e sine squared x is 3 secant squared x over tan x minus e sine squared x sine 2x. Well, that looks like fun. So let me explain what they're saying. They want us to show that when, I left off an n, that when we do the derivative of this, the answer we should get is this. So all we're going to work with is this side, because they say show that the derivative of this is this. So we're going to do the derivative of this, and when we get to the end, that's what we should have. So they're actually giving us the answer. They're just saying, show why. All right, so we're going to take this step by step. Okay, so this is 3 times ln of tan x. 3 times ln of tan x. So here's my f, here is my g. I'm multiplying those together. I'm going to do the product rule. All right, so product rule, g ln of tan x times f prime. Well, the derivative of 3 is 0. So again, basically that piece is just gone, right? So this was g f prime plus, now we have to do f, which is 3, but now we have to do g prime. Here's where the fun stuff comes in. All right, so when we do the derivative of ln tan x, first we do the derivative of ln. The derivative of ln is 1 over whatever you're taking the ln of, which is tan x. Then you do the derivative of what you're taking the ln of. Well, we're taking the derivative of tan x. We're taking the ln of tan x, so we're going to find the derivative of tan x, which I told you earlier was secant squared x. So before we move on to this half of the question, let's clean this up. Okay, so let's just clean this up. So ln tan x times 0, that's just gone. On the top, we have 3 times 1 times secant squared. So that is just 3 secant squared x over tan x, which is what they have there. So we're on the right track so far. Okay, we're on the right track so far. So now we have to move on to here. We have to move on to here, minus. So remember doing derivatives of e's. First we take the derivative of e, which is just e. Leave the exponent alone. Then we take the derivative of whatever the exponent is, which is sine squared x. So if I'm just going to write this down here. If I'm doing the derivative of sine squared x, the first thing I do is I take the derivative of the exponent. So I move the 2 down in front and I decrease my exponent by 1. So I have 2 sine x. But once I've taken the derivative of the exponent, then I have to take the derivative of sine, which is cos x. So I have 2 sine x cos x. Now technically, you're then supposed to take the derivative of x, but that's just 1 anyway, so there's no point. So if you're thinking, I thought you were then supposed to take the derivative of what was out here, well, yes, but if it's just x, the derivative is just 1 anyway, so it doesn't change anything. All right, so here is what I have here, but that doesn't quite look like what's up here. They have the e sine squared x, but they have sine 2x. I have 2 sine x cos x. Turns out that's a trig identity. 2 sine x cos x is sine 2x. And so I ended up with what was over here. We're going to do another one. So they say show that if y is equal to x over tan x, then the derivative is cotangent x minus x cosecant squared x. I have a feeling some trig identities are going to come in here. I have this feeling. All right. So there's a couple of ways you can play this. In the text, they do it using the quotient rule. That is definitely an option and probably the one I would take. So the quotient rule, this would be f, this would be g. So remember that the quotient rule says g f prime minus f g prime all over g squared. Remember, that's what that says. All right, so g tan x times f prime, the derivative of x is 1, minus, and I'm subtracting everything at this point, f, which is x, times the derivative of g. Well, the derivative of tan is secant squared x all over g squared, all over tan squared x. So I have tan x minus x secant squared x all over tan squared x. So that does not look like that over there. Just give me a chance though. All right. So the common denominator here is tan squared x, right? So this would be tan x over tan squared x minus x secant squared x over tan squared x. So I just wrote it out as two separate things, right? Common denominator to the two pieces. So that's all I've done so far. So tan x over tan squared x. Well, this tan will cancel one of those tans, and I end up with 1 over tan x here. Again, the reciprocal of tan x is cotangent x. So if I have 1 over tan, that is the same as cotangent x. Again, that's one of those trig identities. It might be helpful if you had your sheet. I don't have a copy of the sheet home with me. I don't think. I'll look through my calculus and see if I have one that I can take a picture of and send you. If not, there's probably a ton of them online that you can go and get. Minus x times secant squared x over tan squared x. I don't like that. I'm going to write secant squared. I like things in terms of sine and cos. That always makes me happier. So secant is the reciprocal of cosine. So that would be 1 over cos squared divided by tan squared, and tan is sine over cos, so that would be sine squared over cos squared. So keep, switch, flip. So my 2 cos squared x's would cancel, and I would end up with 1 over sine squared. 1 over sine is cosecant, so 1 over sine squared is cosecant. So I end up with cotangent x, because I figured that out here, minus x times cosecant squared x, because I have this x, and I have 1 over sine squared. 1 over sine is cosecant, so 1 over sine squared is cosecant squared. So I ended up with the same thing as up there. I will be giving you a few fun ones to try. Yay! There won't be a ton of these. There won't be a ton of these. Let me say that again. There won't be a ton of these. But it really helps me see. I actually like the one before this a little bit better than this one. I actually like example 2A. Yeah, it's example 2, right? Yeah. I actually like example 2A better than example 2B. 2A really brings everything in. It brought in e's, it brought in lns, it brought in sines and cosines. It brought in exponents, so the chain rule. It really brought in everything. So I really like ones like 2A that are really showing me, can you really tear apart a question and figure it out step by step. So I'm going to give you a few to try, not very many. We will likely have a Zoom meeting on Tuesday. So they're at 2 o'clock. I don't know what your guys' work schedules are like. I know some of you are working. So if that time does not work and there's a time earlier that works better for you, that everybody is free, then you can let me know. But at this point, normal class time, oh wait, I can't do 2 o'clock. The dog has an appointment. Not me, but the dog. The dog has an appointment. So actually I could do 2. I could do 2. I can't do between like 1 and 1:30. His appointment's at 1. I'll be back by 2. So I could do 2. So I can do a regular class time, or I could do in the morning sometime. So it's up to you. So this is it. This is the last new stuff you're doing. We're done. Okay? So your assignment is due next Wednesday. We're going to have a test on Thursday. And that's it. Those are the only 2 things left for you to do. I'm going to give you a few, very few homework questions to do. And that's it. All right? No more homework assignments after today. And just, I will answer any questions that you have. And your assignment is due on Wednesday of next week. Thursday of this week is a test on the last part of chapter 7 and the last part of chapter 8. All right, so we'll talk to you again soon.